Hi, welcome to the New Jersey Institute of Technology website and math podcast. My name is Vanessa. Today I'll be covering basics in algebra. Now, going into some of these math classes here at NJIT, you may have forgotten some of the basic foundations to solving many math problems. Algebra is required in no matter what math class you take, and to have a good and it'll be easier to do these math problems if you have a good understanding of the basics. So I'm going to go over a few problems to help you guys refresh your memory on some of these basic algebra problems. Let's look at this problem right here. Now, if you look at this problem, it may look a little bit familiar, but you may be a little bit stumped as to how to go about it. Here, we're squaring two terms together within the parentheses. This is known as binomial expansion, as in two terms being expanded. Now, the easiest way to go about this is to remember FOIL. Now, if you don't remember FOIL, I'll write out the formula for you. Now, if you have two terms within a parentheses, we'll call them A and B, and you're squaring them, the simple formula to square any two terms is the first term squared, the product doubled, plus the second term squared. So let's apply this rule to this problem right here. First thing we need to do is to square the first term. Now, don't forget that you have a 3, an x, and a y squared. Every single factor must be squared within here. So if you do that, then you get 9x squared y to the 4th. Okay? Now, next thing you need to do is the product doubled. Now, a lot of people don't know what I'm talking about when I say product doubled, but all that means is that you're multiplying the first term times the second term and multiplying it times 2. Okay? So let's try that. And if it's easier, just write it all out. So it's 2 times 3xy squared minus times 5. That's all that is. And then finally, all you have to do is square the final term. Now, hopefully you remember your squares, and then you know that 5 squared is simply just 25. Okay? Now, our last step is simply just to simplify the middle term. So if we rewrite the first term, and now we just simplify by multiplying the 2 into here. So you have 2 times 3 times 5, which gives us 30. And we don't have any other variables to multiply, so we can just bring this here down. And we'll just rewrite the third term. Okay? And that's all there is to it. This is the final answer. Hopefully this brings back memories of FOIL and how to expand two terms. Now let's look at another problem where the two parentheses being multiplied aren't exactly the same. Let's look at something else here. How about this? If we have 2x minus 3y plus z multiplied times 2x plus 3y minus z. Now, if you look at it, the terms are exactly the same, but the signs are different, which means that you can't apply the simple FOIL formula. So what you're going to have to do here is to go to each term and multiply it times each term. So I'll draw some arrows so you can follow along with what I'm doing. Let's go to the first term here. We have 2x. First thing I'm going to do is I'm going to multiply the 2x times 2x here, which will give us 4x squared. Okay? Next one is to multiply the 2x times the 3y. So 2x times 3y is going to give us a positive 6xy. And the final one for this, I'm going to take the 2x times a minus z. Don't forget the minus sign, it's very important. So all we get is a minus 2xz. Now that's it for that term. Now we have to do the same thing for the 3y and the plus z. I'm going to erase those arrows so that we don't get confused. Okay, let's move on to the next term. We have a 3y, a minus 3y actually, so let's not forget that, times the 2x. And all we get there is a minus 6xy. I like to make sure I put the variables in alphabetical order, but that's just me. If you don't need to do that, you don't have to. Next is the minus 3y times a positive 3y. A minus times a plus is still a minus. And then you have a 9y squared. Okay? And finally we have the minus 3y times a minus z. Minus and minus makes a plus. And you get positive 3yz. Okay? So that's that for the second term. Let me get rid of the arrows. Okay. Okay, finally the final term of z. Let's go here and let's draw the arrows. Z times 2x just gives you a positive 2xz. I'm going to start writing on the second line because I ran out of room on the first line there. So next we have a positive z times a positive 3y, which gives us a 3yz. And then finally, it's the z times a minus z. A positive times a negative gives you a negative, and you simply get z squared. Okay. Now this may seem like a lot of terms, but trust me, we're not done yet. We have one more step to do, which is to simplify any like terms that we have on our equation. Okay, and the easiest way to go through this is just simply by underlining and eliminating as we go along. So let's take a look. Do we have anything else with an x squared? Nope, doesn't seem like it. So we can move on. How about 6xy? Oh, here's a 6xy, and it's a minus. So positive 6xy minus 6xy cancels it out, so we can just cross it out. Okay. Do we have anything else with an xz? Here we have a positive 2xz and a minus 2xz, which again come out to 0, so we can cross those out. And then, let's see, we have a minus 9y squared. Doesn't seem like that's anywhere to be found. So let's move on to the next. We have a 3yz. Now, again, make sure you always look at the variables because that determines whether it's a like term or not. Here we have another yz, and it's a 3. So 3yz plus 3yz gives you a 6yz. So let's write down what we have thus far. We have 4x squared minus 9y squared plus 6yz. And the only term we have left is a minus z squared, which we have no other like term for, so we can just bring that down. So we have minus z squared. And this is our final answer to this problem. So it did take a good long while, but as long as you follow the steps that we did here, it shouldn't be too bad. And if drawing the arrows helps, by all means do that on your paper. Now, let's try another binomial expansion, but this time we're going to throw a bit of a wrench in it. We're going to try another one using radicals. Now, radicals are definitely nothing to be afraid of in algebra. If anything, they can make your life easier when you're simplifying. Let's take a look at this problem here. 2 square root of 3 minus 3 square root of 2 squared. Now again, because this is squared and the terms are exactly, this term is exactly squared, we can just apply FOIL to expand it. So let's try. Just in case, I'll write the formula out here again. It's a squared minus 2ab plus b squared. So let's apply this formula here. Square the first term. And I can almost think of this as a variable by itself, same as you would treat an x or a y. So the first term here is 4, 2 squared is 4, then radical 3 squared just gets rid of the radical, so it's 4 times 3. Let me go over that one more time. The 2 squared is just 4. Radical 3 squared is the same thing as saying radical 3 times radical 3 is just simply equal to 3. All it does is get rid of the radical. So, moving on to the next one. Again, if you want to write this out, it's 2 times the first term times the second term. Okay? Now the final term squared is simply not 3 squared is 9. Again, radical 2 squared just gets rid of the radical, so it's just 9 times 2. Okay? So now let's simplify what we have here thus far. 4 times 3 is 12. Now if you want to do this in 2 steps, we can. So let's just do that. 2 times 4. 2 times 2 is 4. Radical 3 times 3 radical 2. Then 9 times 2 is 18. Okay, we're almost done. Let's simplify what we have left. Let's rewrite the 12. 4 times 3 is 12. Now when you're multiplying radicals, don't forget to bring the radical back down. So radical 3 times radical 2 is just simply radical 6. And then plus 18. Okay? And then don't forget, you cannot add radical and non-radical terms together, so don't make that mistake because then your answer will come out completely wrong. So the last thing you can do is, because this is a non-radical term, and here's a non-radical term, these simply can be brought together. So 12 plus 18 would be 30. Minus the 12, radical 6, and you are done. That wasn't that bad, was it? And again, radicals, when you're multiplying them times each other, simply eliminates the radical altogether, giving you a regular number. Now if you like, we're going to try another problem that deals with what we did in the second problem, which was multiplying 2 parentheses that are not exactly the same, but this time we're going to throw radicals into the mix. So let's see what happens. Here we go. Try this problem. Radical 5 minus 3 radical 2 times radical 5 plus 3 radical 2. Again, the terms are the same, but we have different signs. Therefore, we cannot apply FOIL, so we're going to have to do term by term. So let's try it. I'll draw the arrows again, just to make you feel more comfortable with what I'm doing. Let's start with the first term here. We have radical 5 times radical 5. Again, radical times a radical just gets rid of it. So that just simply gives you 5. To the second term, radical 5 times 3 radical 2 simply gives us 3 times radical 10. Okay, that's it for the first term. Okay, so now let's move on to the second term. We have minus 3 radical 2 times radical 5. So that's going to give us a minus 3, because there's no other numbers, right? Whole numbers there, times the 2 radicals multiplied together, which just simply gives us radical 10. And finally, it's minus 3 radical 2 times plus 3 radical 2. A minus times a plus gives us a minus. Multiply these two numbers together gives us 9 times the 2 radicals. It will simply give us 2. Okay. Now if you look at the two middle terms here, they're the same, and it's plus and a minus, so 3 radical 10 minus 3 radical 10 just gives us 0, so that cancels out. And then we have the 9 times 2. So if we rewrite, we have 5 minus 18, and then that simply gives us negative 13, which is our final answer. See? So radicals really aren't that bad. They just take a little bit of thought, and if you remember the little tricks, like if you're multiplying a radical times itself, it eliminates the radical altogether, and you just have what's you just are stuck with what's underneath it. And always remember FOIL: a squared minus 2ab plus b squared. Apply that formula to any time you're squaring, and you'll save yourself the whole trouble of drawing the arrows. Now, what we're going to do now is just go over some of the basics of radicals again, of simplifying and evaluating. Let's try a few examples with how to simplify within a radical and pulling out terms. Let's look at this term right here. It's going to be a very long radical. And inside we have 32x cubed times 2 plus y z to the 4th. Now don't be scared just because there's so many terms in there. All you have to do is just take it one term at a time and see what can be taken out. Let's start with the easiest part, which is the whole number here, 32. Now because we're square rooting it, we can probably break this up. So I'm going to rewrite the radical here even longer so that we can break up everything that can be square rooted into a perfect square. 32 can be broken up into 16 times 2. And then the 16 is a perfect square, so we'll take that out. But let's wait. Let's do the rest of it. X cubed. Now don't forget, exponents of variables can be, are not, you don't have to worry about them being perfect squares. They just have to be divisible by whatever the square root is. So because we're square rooting, it can be x squared times x to the first, and then the x squared can be taken out. Okay? Let's look at this. Now 2 plus y. Now be careful here. Nothing can be done with this because this is a term that has an addition sign within it. So this cannot be touched. This as a whole term cannot be touched. Now looking at this one, z to the fourth, this is divisible by 2 because we're square rooting. This can be completely taken out as it is. So, if we pull everything out that we can take this out as a perfect square. Square root of 16 is 4. We can take this out. Square root of x squared is just simply x. And then this can be taken out. The square root of z to the fourth is simply z squared. And then everything else that could not be taken out must remain within the radical. So what do we have left? We simply have 2, the x, and the 2 plus y. Now to make your final answer look a little bit cleaner, you might want to distribute this term into here so that it looks a lot better. So if we rewrite the final answer, 4xz squared, and then within the radical we simply have 4x plus 2xy, and there you go. All you did here was just simply simplify what was in the radical by taking out perfect squares. Now we'll do one more problem where we just simply take single numbers and evaluate them that are especially raised to a power.